Good morning, students. I am Subbarani, Associate Professor, Emmanuel Research College of Pharmacy. Today's topic is benzene structure and nomenclature. Benzene. The molecular formula of benzene is C6H6. It is the simplest aromatic hydrocarbon or arene. Okay, the structure of benzene or the molecular formula is C6H6. The resonance description of benzene consists of two equivalent Lewis structures, each with three double bonds that alternate with three single bonds. The structure of benzene contains three double bond and three single bond. They are alternate single and double bonds. The true structure of benzene is a resonance hybrid of the two Lewis structure. The true structure of benzene is resonance hybrid, with the dashed line or dotted lines of the hybrid indicating the position of the pi bonds. So, the true structure of benzene is a resonance hybrid with the dotted lines of the hybrid indicating the position of pi bonds. This is the structure of benzene, the resonance structure. First structure, the double bond is converted in next place. Okay, then this double bond is delocalized the next point. So this is the hybrid structure of benzene. The dotted lines means the delocalized of electrons. The electrons in the pi bonds are delocalized around the ring. The electrons are delocalized in the ring. So this is the stable structure of benzene, because each pi bond has two electrons. So benzene has 6 pi electrons. Each pi bond has 2 electrons. So benzene has 6 pi electrons. Some texts draw benzene or a hexagon with an inner circle. The structure means hexagon with an inner circle. Some texts or show that. The circle represents the 6 pi electrons distributed over the 6 atoms of the ring. The circle represents the pi electrons are distributed over the 6 atoms of the ring. So these are the structure of benzene. These are resonance structure. These are the hybrid structure. The hybrid structure are more stable, so the electrons are delocalized around the ring. The pi bond has 2 electrons, so benzene has 6 pi electrons. Some books or draw the benzene structure is hexagon with an inner circle. The circle represents 6 pi electrons distributed over the 6 atoms of the ring. In benzene, the actual bond length is 1.39 angstrom. Is intermediate between the carbon-carbon single bond 1.53 angstrom and the carbon-carbon double bond 1.34 angstrom. So the actual bond length is 1.39 angstrom. This value is intermediate value of carbon-carbon single bond and carbon-carbon double bond. So the value 1.53 angstrom and 1.34 angstrom. Carbon-carbon single bond, carbon-carbon double bond. But the actual bond length is 1.39 angstrom. This value is intermediate between the carbon-carbon single and carbon-carbon double bond. Okay. This structure, the benzene resonance structure, the bond length is 1.39 angstrom. So CH3 single bond CH3, carbon-carbon single bond is 1.53 angstrom, CH2 double bond CH2, carbon-carbon double bond is 134 angstrom. Okay. The CC bonds in benzene are equal and intermediate length. Carbon-carbon bonds in benzene are equal and intermediate length. The nomenclature of benzene derivatives. To name a benzene ring with one substituent, name the substituent and add the word benzene. In benzene ring, only one substituent is present. The nomenclature of name in first the substituent and next the word benzene. For example, in benzene ring attached to ethyl group, CH2CH3 group, The name is, the compound name is ethyl benzene. Then next, in benzene is attached to tertiary butyl group. So the name is tertiary butyl benzene. Then in benzene is attached to the chlorine, chloro group. So the name is chlorobenzene. Okay. In only one substituent present in benzene, first the substituent name, then add the benzene. Many mono substituted benzene have common names. So many mono substituted benzene present in many mono substituted benzene have the common name. For example, in methyl group is present at benzene ring, so the name is methyl benzene. For the common name is toluene. In OH group, so hydroxy group is present in benzene, the common name is phenol. Amino group is present in benzene ring is aminobenzene, so the common name is aniline. So some monosubstituted benzenes are attached in some monosubstituted groups are attached in benzene, we called as the common name. For example, CH group is known as toluene, OH group is attached to phenol, and NH group is attached to aniline. Okay. Then there are three different ways that two groups can be attached to a benzene ring. Two or three different ways. So the two groups are attached to benzene. In benzene ring, two groups are attached. The names are mentioned in three different ways. So a prefix ortho or meta or para can be used to designate the relative position of the two substituents. For example, in 2-bromo group, bromine is attached to benzene. So 1,2-disubstituted benzene are known as orthoisomer. 1,2-disubstituted benzene are orthoisomer. So the name is ortho-dibromobenzene or O-dibromobenzene or 1,2. Position is first position, then second position. So 1,2 dibromobenzene. So the three ways are named in this structure. So ortho dibromobenzene or O dibromobenzene or 1,2 dibromobenzene. Next one is 1,2 bromo group is attached in, one is the meta position. So 1,3 disubstituted benzene in meta isomer. So this name is meta dibromobenzene or meta M dibromobenzene or 1,3 dibromobenzene. The next one, 1,4 disubstituted benzene. So the position is para position. So para isomer. Then first position is Br, then ortho, meta. So para position is attached to bromine. So para dibromobenzene or P dibromobenzene or 1,4 dibromobenzene. So one or more substituents are present. The three different ways of naming. So ortho, para, meta and ortho, para, meta dibromobenzene or ortho dibromo, O dibromobenzene, M dibromobenzene or P dibromobenzene or 1,2 dibromobenzene or 1,3 dibromobenzene or 1,4 dibromobenzene. So these are the nomenclature of benzene. Okay, thank you students.